Hi, I'm Scott Green. My family and I, Kathy Green and my 2 kids, we're here on the east side of Birmingham and are on the final stages of building a sustainable home. It's our passion. We wanted a passive solar home, so we're using the sun as a big part of our heating element in the winter time. We're minimizing square footage, trying to have a living environment that's not only indoors and outdoors. We'll have edible foods on the front side of the house. We have rainwater collection. We have a whole number of systems that we've tried to incorporate in the home. You know, a home that's sustainable, that doesn't take a lot of maintenance, that is very energy efficient, that doesn't cost a lot to heat or cool, that has natural ventilation, natural lighting, and just a place that we can enjoy and use as an educational tool.
We want to show that this can be done. This home will be a net zero home, therefore it's going to produce more energy than it consumes. And that's extremely important looking to the future and where we need to come in the built environment. The exterior of the home is constructed out of this block. It's made by a company called Fastwall. What they do is they take old pallets, when they reach into their life, they grind it up and they mix it with Portland cement. Then they create this form. It's 2 feet long, 12 inches deep, and it has insulation inserts. And it's probably 4 to 5 times more energy efficient than your average stick-framed home. Pavel here worked on a lot of the installation.
Yeah, so it installs, stacks together. We have a corner block and we have a sample of a single cell. They lock together. It gets vertical rebars and horizontal rebars, and then the cells get filled in with concrete, create a channel which interlocks everything, and have a solid wall with concrete, good insulation, and surface prepared for interior finishes and exterior, which is the stucco going on right behind us.
We're here in the kitchen / living room. We still have plenty of access to that southern exposure, a lot of natural light. The cabinetry is built out of FSC certified lumber. We have a water level indicator for the rainwater harvesting system. Right now it's showing it is 83% full. You can't see right now, but this home is 100% lit with LED lights. They're extremely long lasting, consume very, very little energy.
Yes, there is a tree inside.
So one critical aspect of the house you see is the tallest part, which is a tower of sorts, and it's going to help us with the thermal draft effect. So we can open windows low, open windows high, and we're going to be just like an attic fan, but without having to have the motor, because it's natural. It's there, and it's going to draw the heat up to the top, and it's going to suck through the windows.
That's why we kept it so open. That's why the threads have no back, and as few members as possible to let the light in and allow for airflow.
So on our windows, we're looking for performance. We have insulated windows. Our U factor, which is really just a measure of how well insulated the window is 0.28. Here in the southeast, you really want to be below a 0.30. As far as our solar heat gain coefficient, which is extremely important here in the southeast, you could compare this to maybe having a tent on the window of your car. It allows less radiant heat to penetrate. With this system, what we have is 5 different air handlers throughout the home, creating their own climate zone. So on the west side, during the summer, that particular point of the home is going to be hotter than the east side, let's say this afternoon. That particular unit is only going to be pulling refrigerant, while the other one may only be running the fan. The SEER rating, which this is more engineering terminology, is around a 25. That's probably 50% more efficient than the most efficient heat pump on the market. What we have here is our mechanical room for water. So as we told you, we're harvesting 3,400 gallons of rainwater. We've got it plumbed, so when the laws change, we're going to be able to purify that water and use it for their potable use, all the drinking water, showers. It comes through a 20 micron charcoal filter to a 5 micron. We're able to monitor how clean they are through our pressure gauges. The pressure drops, it means it's probably getting time to change one. Then it goes through a UV light. Well, here's access to one of the cisterns. Each one is 1,700 gallons. We have them tied together.
This roof and the square footage of this roof, an inch and a half of rain will fill up 3,400 gallons. So we get an inch and a half of rain pretty often. The movement and sustainability, it's not just a fad. And us building smaller homes and using less resources and using them wisely after they're in place is here to stay.